Okay, greetings to one and all. Thank you for joining me in this video presentation, whether you are viewing it on YouTube or if it has been presented as part of a webinar. Thank you nonetheless for taking the time out and participating in the message that I am about to share. I would, however, like to point it out to everybody that this presentation is in actual fact brought to you by EmComm Pty Limited, a commercial community-based emergency communications radio network. And of course, what we will be looking at today from the EmComm perspective is two-way radio, an emergency communications solution. As I say, it is brought to you by EmComm Pty Limited, and you can see that my byline there says, we should not rely on cellular technology. And that is the whole purpose of this webinar or presentation overall. I need to go through various aspects, and I am hoping that in essence to change mindsets as we move forward. So this presentation is not to provide you, the viewer, with a fast food drive-through experience. In other words, I am not going to point anything out to you in 30 seconds or less. I am going to take you through an entire process, which in actual fact will give you a broader insight into the problems that we experience. So if you're looking for this fast food drive-through experience, if this is what you are after, you are definitely in the wrong place altogether. This presentation is intended to introduce knowledge. That is the whole purpose of it. And it is through that knowledge that you will in actual fact find yourself in a position whereby you can make a better informed or an informed decision. The following EmComm Radio YouTube videos are recommended viewing for a more in-depth understanding of the situation that we find ourselves in, not only as a community, but definitely as a country. And of course you can view us at www.youtube.com, and that is /@EmCommRadio/videos. There is a presentation that I have put together called Load Shedding, the General Impact on Society and Communications, and introducing the EmComm Community Emergency Radio Network Service. Now, both of these videos are going to be supplemental to what I'm about to present, and it is recommended that you watch both of the videos as well as the video that in actual fact I am about to point out with regards to the Disaster Relief Cert YouTube videos, which are also recommended viewing for a more in-depth understanding again of the situation that we are in. And this video is the Disaster Relief Cert Get Ready Now campaign webinar, which is available to everybody at a cost of 50 Rand for those that attend the webinar. And there is a cost implication purely to cover the cost of the actual webinar, the webinar platform, and of course all the internet connectivity, etc. You may view that at youtube.com/@disasterreliefcert/videos. You are also encouraged to register for the following webinars and training. Now, as Disaster Relief Cert, EmComm Pty Limited and EmComm Training Academy, we are in the process of providing radio communications training for the general public. That again has got a cost implication of 100 Rand. And then specifically for Disaster Relief Cert volunteers, there is the Disaster Relief Cert induction training, plus the basic radio communications training. Now I need to point out that the basic radio communications training is of a much higher level and standard than the radio communications training for the general public. And of course the Disaster Relief Cert volunteers can also do the disaster area damage assessment training modules. So those three modules are available specifically for Disaster Relief Cert volunteers, and these modules are available at a cost to the volunteer at 600 Rand a year, which enables them to undergo annual training of the same modules, getting all the new, current and up-to-date information, which ultimately does not mean that they're going to pay several thousands of rands, etc., to do the training. Now, on the disaster relief CERT volunteer training, there is most definitely the availability for the CERT volunteers to purchase hard copy, not PDF format, hard copy training manuals, and there is a cost implication on that. And of course, they can contact EmComm to get the pricing and to place orders and have it delivered, etc. Now, the very first thing that we are in actual fact going to look at with regards to the training session moving forward is the critical infrastructure or the systems which will probably fail. From that point, we're going to start looking at some facts. We'll have a quick look at understanding RF. Don't worry, we'll describe RF during that module. We'll look at a cellular network design. We'll look at a two-way radio design. Then we will look at pros and cons, what the solution is, what is required to implement this solution, and of course the equipment and other costs. So when we start looking at specifically the critical infrastructure or systems which will probably fail, the very first thing you need to understand is everything can fail. It doesn't make a difference what it is. All infrastructure, all essential service, all service delivery, to name a few, can be at a point of failing and preventing us from moving forward. So that being said, the very first thing that kicks in is electrical supply. We currently are experiencing this, and at the time of recording this particular presentation, it's 1400 hours 05 on the 16th of February 2023. We are currently experiencing electrical failure, and this is now at this stage mainly due to load shedding. Now, one of the reports that was put out today, which hasn't come up in the presentation, we will cover it later, but there is the potential risk that the whole Roodepoort can be subjected to a total blackout. So we will discuss that in a little bit more detail, because ultimately at the end of the day, no electricity, water supply will follow. We've experienced that in various areas throughout the country, that following electrical supply or the lack of electricity, the water supply now fails, purely because of the fact that towers cannot be pumped full with water, no electricity, no running of the pumps, etc. and etc. Now, you know, if we sit back and really look at this in a logical perspective, let's start looking at our businesses, our factories, our manufacturing plants. They've got no electricity. They can't run machines. They got no water. Because they don't have water, they definitely can't prepare foods. So our food security now becomes a problem, and will probably, we will start, well actually we are already starting to see the implication of food security being put in jeopardy as a result of electrical supply and of course the water supply failing. Then on top of that, essential services, again we are currently experiencing this one. Just going back to the fast food security, in December of 2022, one of the major fast food stores closed 70 of their stores purely because of the fact that they couldn't source chickens, and therefore were unable to provide the fast food industry any sort of solution. So now you've got people coming home from work, they can't go to this fast food outlet because they got no chickens. Now the kids at home are upset, so that's a problem. And then last but not least, and I bring this up as the last item on my list. Look, there's a lot of other areas that are going to fail, but I am looking at what is crucial and critical to sustaining life. In other words, what is it that is going to affect you on a one-to-one basis that could cost you your life. You know, service delivery, let's say, for example, garbage isn't collected. Well, it's not going to kill you. And a lot of people are going to say, yes, but all of the diseases that are brought with it, yes. I agree with you. It will bring a lot of other diseases. But we need to go back, I think it was Lebanon, where the garbage is piled up mountain high, piles of garbage on the streets. Well, the population is still there. However, that being said, communication is a vital aspect of failure. And we will discuss that in more detail as we move forward. So, let's look at some facts. South Africa has now experienced load shedding virtually on a daily basis since January of 2022 up until now February. I've got on screen when I started this series, January 2023. Last year of 2022, I believe it was 220 odd days in total. Well, needless to say, from the 1st of January 2023 up until today's date, we have been subjected to load shedding on a daily basis. Secondly, cell phone networks and battery towers, this is a fact, need backup solutions to continue operating when there is no electrical power available. Another fact that we need to look at is that cell phone networks and towers are interlinked with other cell phone towers using a combination of fiber, internet and other radio system backhauls. We'll describe that in more detail as we move forward. Fiber internet connections also need battery backup solutions to continue operating when there is no electrical power available. Battery backup solutions, however, need to undergo a recharging stage between load shedding. So let's look at this. No electricity or no electrical supply, therefore no recharge. So even if we do put batteries in, well, unfortunately, they cannot be charged. Another fact, load shedding, a passive accomplice. This is news headlines, and I'm crediting the news outlets at the bottom of each of the headlines. So load shedding is ultimately a passive accomplice, and in this particular item it was referring to criminality. Another fact, Vodacom spends record 5.8 billion on SA network as it battles load shedding. And my question is quite simple. How long do you think Vodacom is in actual fact going to continue doing this? And even if they do it, just ask yourself this question. What impact is it going to have on your current contracts, especially when they come up for renewal? Load shedding sees a higher frequency of crime being committed. Another headline. Load shedding gives wireless ISPs an edge over cellular networks, according to an expert in the field. Why your cell phone loses signal during load shedding? There we have it. All the skeptics out there are actually stating it never happens. Ladies and gentlemen, don't take my word for it. Look at what has been reported on national news. It's a given fact when you start coupling that up with no electricity, no backup charging and everything else. You can put batteries in, you can put solar solutions in, and criminality removes them overnight. So we've got the experts, we've got the companies specifying why your cell phone loses signal during load shedding. Look, here's another one. Different newspaper. Consumers suffer as load shedding affects cell phone signal. Network blackouts loom as load shedding depletes mobile tower batteries. Widespread cell phone strife for users due to power cuts. Hundreds of MTN and Vodacom network sites down after the KZN floods. Now, you know, I brought this one in specifically to show you it doesn't just have to be load shedding. But a natural disaster, a disaster within a particular area can bring it down. And ladies and gentlemen, that could be your area. Now, another fact is generally people are unaware that cell phone communications have collapsed or failed. And to explain that, in many instances, you pick up your cell phone, you dial a telephone number, beep, 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 oh no, number's engaged, I'll give it a bit of time, and you're traveling down the road and you've gone from one network cell to another network cell, more explanation later, and then you dial that family member and there we go, everything is hunky-dory fine. Unfortunately, you are not aware of the fact 99% of the time that the actual cell tower or cell phone network is unavailable to you at any given location. Purely because those calls are going absolutely nowhere due to the failure of the networks, or as a best case scenario, they might be connecting to the local tower, and as I mentioned previously, local towers need to connect with other towers in order to get the communications through. These type of communications don't work on magic dust and fairy poop. They do in actual fact require a very specific path or route in order to get your message across. That being said, another fact, the problem with this instability in cellular connectivity is that when the cellular network is most needed, you will not be able to make emergency calls. Yes, sure, your cell phone will probably come up and say emergency calls only, and you dial the number or you activate it and nothing. I'm not talking about just picking up your phone to phone your wife or your son to tell them you've fallen off the ladder and you need help. Whichever way, whether you've fallen off the ladder, whether you are dealing with some other emergency, whether you want to actually report a motor vehicle accident, it might not be your life, it might not be your family member's life, but it's definitely a life of a loved one somewhere that could be impacted by no cellular network. So this is where you really and truly have to consider a shift in your mindset and accept that these problems are occurring. Over the last couple of weeks, I've been asking my local community, every time that I notice that I've got no service on my cell phone, to check their phone. And the problem is that when they do check their phone, not everybody is using their WhatsApp, for example, on a fiber connection. They don't even know it because they only get the message when the connection actually is restored. And it is on this basis that we need to understand RF. And before we look at RF, we need to establish what makes use of RF. Simply put, RF is used in all cordless and cell phones, all radio and television broadcast stations, Wi-Fi, Bluetooth, satellite communication systems, two-way radios. Just look around you. As you're sitting listening to and watching this presentation, just look around you and find which devices fall into any of those categories, and you'll soon discover that every single one of these components, these tools, these necessities rely on RF. You also need to understand that many of the devices we use today generate RF, like microwave ovens, garage door openers, TV remote controls, computer keyboards, and even computer mice. Yeah. All of these things are actually utilizing RF. And RF really is just a simple measurement that represents the oscillating rate of an electromagnetic radiation spectrum. So for those of you that come from the amateur radio side and also the CB crowd, you'll understand what I mean by 27 megs. That is the measurement representing RF. Now RF, in simple terms, we need to state that cell phones and two-way radios. Now let's be clear about this. Both cell phones and two-way radios use RF in order to operate. And there are many skeptics out there that are going to state, well, cell phones use RF, two-way radios, what is the difference? Actually, there's a very big difference. Now, when we look at cell phones and two-way radios, what they do is they actually convert. This is a very simplified layman's term. I'm not going to go into any technical detail on it because I'm not at such a high technical level that I could explain it. So I'm just going to simplify it for the average man of the street. Simply, both cell phones, two-way radios, and other communication type devices will convert spoken voice or data into electrical signals, and that particular device will then send these electrical figures out into the air, which we cannot see. You'll see later, I actually have a slide or in one of the presentation, because the electrical signals send out into the air, we call it an airwaves or refer to it as the airwaves. So when these devices send the signal, that voice and spoken voice and data as an electrical signal in the air, we consider this transmitting of a signal. Then on the other side of the fence, you've got other devices that will collect or receive the signals, and these are the receivers. The receivers will do the reverse. They'll convert the electrical signal back into a spoken voice or data. Spoken voice, we can hear it being presented to us through our speaker system, and if it is data, we'll be able to read it as a text message. So simply put, RF is really just the electrical signals found in the air around us, otherwise known as the air waves. So there's a cell phone with the where, how, what, who, why, and of course all of that gets transferred into electrical signals that is put out. Now, when you start looking at, and I said earlier, we need to look at what is actually happening with regards to the cell phone versus two-way radio. We need to have a look at a cell network design, and in this sense, the term cellular or cell is due to the manner in which a network is designed. And as pointed out previously, cell phones use RF to communicate. However, due to their physical size, there are limitations such as power that each cell phone uses for transmitting purposes. Power plays an important role in the design because the lower the power, the shorter the distance, and of course the higher the frequency, also the lower the distance. So to give you an idea, we've got a hexagon cellular network or cell network, very much like a bee's hive, honey beehive, where they in actual fact create these little cells, and each little cell contains certain amounts of honey, etc. Whereas on the cellular network here at the points, if you take a look here on the top left hand side where there's a number 2 and a 16 and a 9, that would be the position of one cell tower. And then if you move slightly to the right center, you got 6, 20, 13, that'll be a second one. And then right up at the top right hand side, you got 7, 21 and 14. And yeah, they actually do depict certain cell phone towers. Some of them are very small, some of them are low, some of them are high, and of course this is now what builds up your cellular network. And as I said previously, the cell network in actual fact does require internet connectivity or other radio connectivity between the 2 points. So where you look at 7, 12 and 14, they would in actual fact have to connect to 6, 20 and 13, 1, 5 and 6, and this could be done by other radio transmitting and receiving apparatus, etc. Now, when you take a look at this, you can see that if you are going to transmit from number 7 here on the top and you want to talk to number 8 at the bottom, you've got various cell networks or cell towers that your data or voice will have to pass through to get to number 8. And of course, if one of these is in actual fact not working, then you're not going to be able to use that route. However, the technology is designed that it'll automatically switch you through another network. Well, that's all fair and well. One cell phone tower goes down, not a train smash. 2 go down, not a train smash. You probably still got 3 or 4 that you can connect through. However, when you look at a complete suburb or in a complete area or 20 or 30 kilometer radius, then all of these cells are going to go down, and 7 to 8 you are not going to be able to talk to anybody. So to give you an idea, I said you get some that are high, you get some that are not so high and smaller in design. You see on the left hand side they have in actual fact camouflaged them, and the one on the extreme right, believe it or not, where you see this little white piece at the bottom, that is actually where the antenna is sitting for the cellular tower, and of course that will have an impact on the area of coverage. So a cellular network by design, as I've said to you, I'm just going to very quickly run through these. You'll see that in essence what you do in actual fact have is multiple towers all over the place with people trying to talk to each other. Between two towers there might be a microwave backhaul, and while that is up, the young lady on the left can talk to the older lady on the right. You've got communications, but that communication will fail if that wireless backhaul fails. And of course then those two ladies are not going to be able to talk to each other. Now the same thing will in actual fact apply when you start looking at a much broader and wider area. So the young lady now wants to talk to the young gentleman at the bottom, or the young lady at the top wants to talk to the gentleman at the bottom. Of course, now through a fiber backhaul, they can in actual fact accomplish their communication need. The thing that needs to be considered, however, is what happens if the fiber backhaul fails. You'll see that the young lady on the left-hand side will not be able to communicate with the lady on the top right, or the gentleman down to the bottom center, but the lady at the top will be able to communicate that way. So that's what happens when a fiber backhaul occurs. Now the other thing that we need to do is we need to move into the two-way radio design, and you'll notice that quite simply we've got multiple devices. In this case I've got two gents on the left and right and a vehicle in the center, and of course there is some kind of routing, or we are in actual fact discussing the design of a network. In this case we use simplex communications, which is really radio communications that uses a single frequency. In terms of cellular networks, they are using multiple frequencies in order to communicate, so it's not in the simplex. We'll discuss it in the next slide. Now the simplex communication is the simplest form of communications. You actually communicate directly from one device, a handheld, to another handheld, or to a motor vehicle, between the devices, and there's nothing special or fancy that's needed, and it all works on just having the cell phone, the radio charged, which can be charged off a car. The car battery will be charged when you run in the vehicle, etc., etc. However, you must be aware of the fact that you are limited to line of sight principle, which really is, if you can see it, you can speak to it within reason. The next type of communication is our duplex communications, or otherwise utilizing repeaters. Here we use two frequencies, maybe more depending on the type of network setup. And of course each device now will firstly communicate with the repeater, and then will retransmit that very same signal back out on the second frequency, so that the other devices can hear it. And of course in this particular case this is very similar to what happens with the cellular network. Now if you go back and look at the cellular network, as I said, the lower power is going to affect the distance, so therefore each of the cell phone towers might be 1 kilometer, maybe 1.6 kilometer apart. So each tower is 1 to 1.6 kilometers apart, and if you are anywhere within that range, you will be able to access the nearest tower. When it comes to two-way radio, because of the higher power capabilities both on a handheld, if I'm not mistaken, a cell phone probably transmits at about 0.1 of a watt, whereas a two-way radio handheld can do 5 watts. Motor vehicle radio, you could do as high as 60 odd watts on a commercial network, higher wattage as a radio amateur. So of course that now again, line of sight, if you can see it, you can talk to it. Higher power, you generally will be able to get through to it in a much clearer aspect. And when it comes to two-way radio, You can also use what's called a relay station, still using either a single frequency or multiple frequencies. What you can do is you put somebody with a mobile out on a high site or a high area, and of course your two handhelds can transmit to that particular vehicle, and that person in the vehicle can retransmit or relay the message to other people on the network that others can hear it. This type of communication, you can't, if you think about it, when you look at a cell phone does not talk directly to a cell phone, whereas a two-way radio will be able to talk directly to another two-way radio. And as a result of that, if you find that one handheld can't talk to another handheld, one handheld might be on this side of the mountain, second handheld on the second side or the other side of the mountain, and you can get a vehicle up on top of the mountain, then of course that is where the advantage of the relay station is. And the overall advantage of a relay station ultimately is that during times of disaster and emergency, communications can most definitely be established between various parties and maintained throughout the lifespan of a particular operation, whereas that cannot be said with the cellular telephone network. Some of the pros and cons that need to be considered with regards to both the cellular network and two-way radio. Firstly, let's just look at cell availability, common and already in use. Every single person seems to have a cell phone, but many people either don't know what a two-way radio is, even though they both use RF, the one we know as a cell, because of its network design, two-way radio, because of its network design being different. Not many people know about it, firstly, and secondly, it's not very popular. The price, when you look at your cell phone, firstly, it is expensive on all accounts. You buy a cell on contract and you have to renew your contract. Normally you get another cell phone because the previous one now can't store enough data, and so over a period of 10 years you actually spend a lot on the actual hardware device, and then of course you are also spending a lot of money in terms of data and cell phone calls or airtime. Compared to two-way radio, there's a once-off price, and it's generally cheaper than any cell phone at any given moment in time, and that goes for your two-way radio vehicle mounted equipment. Definitely is a lot cheaper than many cell phones. And of course, any airtime or data not really needed. You might have to pay repeater high site fees, which is also again definitely cheaper than what we on average spend with calls. The commitment, you need a contract with the cell. Usually two-way radio will be on a month-to-month or a 3-month basis, so you can cancel. One thing about the two-way radio, it is subject to an annual license fee because all radio equipment has to be licensed through ECASA. Now, the area of coverage, well, because of the cellular network design, you definitely can have a national network where you can talk from Durban to Cape Town with very little sort of aggravation, whereas when you start looking at two-way radio, simplex, depending on your terrain, depending on where you are, depending on the radio equipment you are using, you could at a push operate. I'm not saying it's impossible, but you can up to 20 kilometers, whereas that's using mobile, maybe 5Ks with a handheld. Again, there's a lot of factors. This isn't a radio communications training program, which is why right up front I recommended that the general public do radio communications for the general public with the EmComm Training Academy in order to get a better understanding of this. Now, when we start looking at our repeater coverage, the con can be only 50 kilometers. So normally you can go a little bit further than that, but you're definitely not going to be able to cover 500 to 1 kilometer sort of range that I mentioned as a pro on a cell. And I say that because Well, now I need to also be clear that when I look at the cell's average distance, it's not where you can talk from point A to point B, but from where the device can connect. So the cell phone will probably connect to a tower 500 meters away to 1 kilometer away, whereas a two-way radio on simplex you can cover up to 20 kilometers, 5 on average. It's already 5 times higher than your cell phone, and of course the repeater is 50 times higher at 50 kilometers. That being said, we need to move on and look at the overall solution. So I've just provided a very simplified method of looking at how we can establish radio communications using two-way radio, specifically for emergency communication purposes. And in this particular case, I need to point out that the whole purpose of utilizing the community emergency radio network is to ensure that there are capabilities of providing emergency communications to local communities, and this is all going to be as a result of cellular telephone failures, etc., etc., etc. Now, what I would like to point out is that in actual fact I am going to take a look at breaking this down, the solution in detail, so that we can establish a clear concept of the community emergency radio network. So what we do is, let's take a complex, for example. It might be an estate, it might be a housing estate, a local residents association. You can define that as you see fit, but I'll just term it complex one, which is situated in a particular suburb. Now, each of the residential holdings or residential homes, businesses within that complex area should be equipped with a two-way radio. I've just depicted this with handhelds. You could be a combination of handhelds or mobiles or base stations. We'll discuss that in more detail. Now, I want to extend this because remember we've said we got a capability that we are able to communicate maybe up to 50 kilometers. And what happens is, in complex one, we have an emergency. We need to be able to communicate much further away to be able to get assistance. So in a different area altogether, again still under the community emergency radio network, we can define a particular area. In this case it could be Ward 98, and we set it up as a suburb 2. Okay, so within that particular ward, we're going to do something very similar. We're going to set up a lot of people, households, whatever it is in the particular area with a radio apparatus. As I said, it could be a handheld, it could in actual fact be a base station or mobile. But what actually happens now is, now we're going to look at simplex communications in the smaller sort of area of coverage requirement. So within the complex, using simplex, all of those particular radios can in actual fact communicate with each other. The problem that exists is complex 1 at this point cannot talk to suburb 2 because they might be out of range on simplex, or they just might have a ridge or something between them. And this is now where we need to look at a repeater capability. So when we put in a repeater, what it means is both complex 1 and suburb number 2 will be able to have two-way radio contact with the repeater. Now in this particular in this particular instance, the blue line depicting the duplex or repeater operation is two-way. In other words, complex 1 will talk on the first frequency to the repeater will talk back to suburb 2 on the second frequency, and then suburb 2 can hear what has been said, and we establish communications that way. Now, let's say, for example, any member of the the complex 1 or suburb 2 that is subscribed to the community emergency radio network, they got a family member that travels around within range of that repeater. That family member could in actual fact put a two-way radio in their motor vehicle. Again, talking to the repeater will be able to talk back to the family members. Now, I don't think I need to point out the fact that in essence we can have multiple family members. This is just a simple representation of the radio network. Everybody that's got a cell phone could also have a handheld radio, and when the cell phones go down, they can still be able to talk with other suburbs and other family members that are driving around the particular areas. So when we look at this, suburb 2, of course, we'll be able to use possibly simplex to the position of that motor vehicle because it's within maybe that 5 kilometer proximity that I mentioned earlier. There might not be any obstacles, buildings, trees or otherwise, and of course it's within a line of sight. So looking at what I've done here, Fairland could in actual fact still be talking to Randburg, but unfortunately won't be able to talk down into Princess Haldecrane sort of area for complex number 1. Now we can take this and extend it even further. Now, because of the fact that EmComm Pty Limited and EmComm Training Academy, which is under the auspices of myself, Chad Milam, I didn't introduce myself, so my apologies for that. I'll do that now. I'm Chad Milam. I'm a director of EmComm Pty Limited, but I'm also a director and I am a director of Disaster Relief CERT. Our goal of Disaster Relief CERT is to provide our volunteers the opportunity to prepare them to be able to assist in times of disaster, and hence the reason Community Emergency Radio Network, let's bring in some CERT volunteers. Now, I'm only going to show CERT volunteers who are operational as mobile units. We could have a CERT volunteer down in Complex 1. We can have several CERT volunteers in Suburb 2. Ideally, the goal and concept that I've got within each complex, we have 10 volunteers who are CERT registered or Disaster Relief CERT. And for those of you that don't know the meaning of CERT, what it stands for is Community Emergency Response Teams. In other words, we want to train people within Complex 1 to be able to assist the local community. Firstly, the other complex members who are not CERT volunteers, and then the surrounding local community, and the same applies in Suburb 2. Right, so looking at our CERT volunteers, now we start bringing in other capabilities that Complex 1 via simplex communication can speak to a CERT volunteer in a vehicle who might be on the outside, and of course we could have a second vehicle that the two CERT vehicles can talk to each other. Now just automatically you can see Complex 1, the person that wants to talk to or pass a message on to the second volunteer. Sorry, I said volunteer 1 and 1. It should be volunteer 1 and 2. Basically, there's a relay station with the first vehicle that the complex member will talk to. Then, of course, we can extend that further, bring in the repeater capabilities, open up and just broaden the whole communication aspect throughout, which then also means that Suburb 2 can talk to the repeater, that can talk to CERT Volunteer 1, who can in turn also talk to the second CERT vehicle, also marked 1 unfortunately, and we've just extended the range of communication capabilities. Now, depending on how the network is set up and what the residents require, EmComm naturally using digital radios will be able to possibly provide a communication channel where personal communications may be undertaken, but primarily this is a community emergency radio network where we will only allow and each community should only allow emergency related radio communications, and possibly set it up in such a way that they can do a weekly check-in, or just ensure neighbors or their radio equipment is tested, etc., etc. Now as we move forward with this, we also need to bring in a base station capability, and of course a base station is somebody that will have probably a mobile radio, but they've got a power supply and additional battery backup, external antenna. We'll discuss that later. All of that then gets put up, and the very same principle applies, that we can in actual fact get the message out in a much broader area. Also, your base station, who might be outside a suburb too, which is affected, or the complex which is affected, may very well be able to pick up a telephone and contact an ambulance where an ambulance is needed for somebody who might lose their life if they don't get any medical assistance. They could also make contact with the ambulance once we get the ambulances back onto two-way radio networks and offer PTT. Now, I just want to briefly state that PTT is still push to talk, or PTT OC, PTT push to talk, OC over cellular. Cellular network goes down, not going to be able to talk. Most of the emergency, private in particular, emergency services are running on the PTT or the push to talk networks or network radios. And of course, during times of these outages, they don't have communications, despite what they may in actual fact tell you. Okay, so EmComm Pty Limited is bringing and providing the community-wide two-way radio communications. I have only specified it as community-wide two-way radio communications in this advert, purely because of the fact that we can do it for commercial purposes, business purposes, personal use, but primarily this particular solution that I'm putting forward covers primarily the community emergency response team networks, and that is what we need to be able to concentrate on, generally speaking. So, what is required to implement the solution? First, you, the viewer, the subscriber, needs to decide whether you will be a base station, a mobile station, for some reason my slide doesn't want to work and it just died, so let me just reopen that and see if the keyboard is going to work, because it seems to be wanting to write all over my screen. So you need to decide whether you want to be a base station, a mobile station, a portable station, or a combination of all of the above. Please forgive the way that this is coming up. For some strange reason, it's trying to do things I didn't realize it was going to try and do, and that was edit the PDF. Okay, so base station, you need a two-way radio. You'll need a power supply, an external battery, and an external antenna. Those are the four things that are required to run a particular base station. When you look at the mobile station, you probably use the same radio, but in this particular case, you will use a different antenna system, and that's all that you are needed, because your car's already got your battery, etc. A portable station, on the other hand, again, bearing in mind a little bit shorter range, you are only looking at a handheld radio. So you can automatically see a base station becomes expensive, or is more expensive than a mobile, and a mobile is more expensive than a handheld. However, you could choose to have all of this as well. You could have, as a base station, you can have a radio in your car, in which case whatever radio you put in your car, you need a mobile antenna for. Whatever base station, you need a base antenna. You also need a battery and a power supply to run it. You can also couple up solar systems to charge your battery if you don't have a power supply, and run off of the battery, etc. So there's a couple of options that can be implemented, and then of course you can also have one or more handheld radios. So the question was, what is required to implement the solution? Simple: people and equipment. I've just covered the equipment. Now we need at least 2 residents in complexes or within the local community to subscribe to the community emergency radio network using simplex. Why 2 or more? Well, you need to talk to somebody, so you need 2 or more people. Then, of course, you would also need 2 or more residents of a local suburb or community that is in the area that you are going to be able to communicate with. And of course, we will need registered disaster relief cert volunteers also available in the complexes and in the local communities, so that there are additional people. Now, I've stipulated here that a minimum of 150 radios are required for a repeater solution, which will cover many suburbs or complexes as a whole. And I've done this on one particular type of concept. However, I can tell you that figure is closer to the 200 to 300 mark. If we were to look at putting in dedicated repeaters specifically for communities. So this needs the buy-in of the community on a pretty large scale, which is the reason why I've made these videos available. And for every person who watches the video, I ask you, share the link with other people. The more people we get up, speak to your residents associations, speak to your local communities, use your social media, and see if we can, build the networks on a much larger scale, providing a much higher coverage area. So the more people with radios within a given area, the greater the communication capability overall, and this of course is definitely intended for us to save lives in the long term. Okay, so, as I said, the more people in an area, the greater our communication capability, and in addition to that, we will achieve what we intend to achieve with an EmComm community emergency radio network. And that is the capability of people, of houses, of businesses being able to communicate with their neighbors, with each other, into other suburbs, with disaster relief cert volunteers, with family members that are mobile. They might be in other suburbs or complexes, and ultimately at the end of the day to, in actual fact, provide emergency communications and summons help by ambulance, fire or otherwise. We also need to have controllers. So within each complex or within each suburb, the people that come together need to determine who is going to act as a base station, who will become a controller, who will be responsible for doing maybe weekly or even nightly or whatever schedule you want to put up, check-ins, and just participate in the community as a whole. It's also advisable that those base station controllers are in actual fact registered as disaster relief cert volunteers. It just makes life so much easier when it comes to sharing of vital information, especially when it comes to emergency related or disaster related incidents in terms of preparedness. Now, the actual cost of the implication, I'm going to be quite clear. These are estimate figures that I'm presenting because everything that has taken place around us, especially with imported product, it is all subject to the rand-dollar exchange rate, our petrol rate, our load shedding and everything else. So a base station, radio, power supply, battery, antenna, you're looking at approximately 9,000 Rand. This is again reason why it is advisable that your base station operators or controllers, you don't have to have two, but it is or more. It is advisable so that not one person is responsible for doing check-ins or whatever. You can rotate, you can work shifts, but a base station is on the expensive side because of the amount of equipment. And then if you plug in solar solutions on top of that, that will escalate the price as well. A mobile station, just a rough estimate, as opposed to the base station of 9,000, you're looking at about 6,000 to set up a mobile station. Look, it's usually a little bit cheaper. I've played it safe here to give you an indication, and it's purely an indication. Everything is subject to the rand-dollar exchange rate, and of course a quote at the time of purchase, and quotes even don't hold up for longer than 7 days. In some instances, the quotes I'm receiving valid for 24 hours, and then we got a requote. Then a portable handheld station, you're looking at about 2,800 Rand. Usually I try and make available any of the specials that come through. So you're looking at approximately 2,800 Rand for a handheld station. However, you do have a possibility of also using a portable station or handheld radio with an external antenna, which ups the price, but it will give you a little bit of extra coverage. Now, in most residential properties, for example, a lot of those complexes, for example, on Constantia Drive, Roodepoort, Constantia Kloof, Roodepoort, they might not, in actual fact, need external antennas. However, when you look at the distance from one end to the other, they may very well need to do it. So that is something that needs to be taken into account. Now, when we start looking at monthly or annual fees, again, just a simple estimate of the fees. When you look at a simplex radio license on the solution, the public are going to pay, I've said annually, that's actually monthly. That's a monthly fee. That's what I meant to say. It's a monthly fee of 200 Rand, but you pay it on an annual basis. Whereas the CERT registered volunteer will only pay 15 Rand per month, also on an annual basis. So annually you pay a once-off fee then of 240 Rand as a member of the public after you have purchased your radio, your handheld at 2,800, and that's your total cost. So ladies and gentlemen, when you look at the handheld solution, it is not that expensive. Let's be quite honest. In order to ensure that you have got emergency communication capabilities, 240 Rand after spending 2,800 or even 3,100 or 200 Rand is really not a high expense. Handheld radios, they can last you for years and years, as long as, when you do the radio communications for the public, you'll understand that there is a way to ensure battery life is extended, but you can purchase battery spares are available. Usually they don't get damaged. Base station equipment susceptible to lightning, that is something you'd have to consider, but again, get it up on insurance. Hopefully the insurance will cover you. Now, when we start looking at the monthly repeater fees, unfortunately there is no other way around this, but this is a monthly fee of approximately 250 Rand per month per radio. Now, that could work out a little bit expensive if you've got a base station, a mobile station, and a handheld station, all wanting to connect via the repeater. It does work out a little bit expensive, but I'd encourage you to think wisely about what you in actual fact are doing with regards to, what is needed equipment-wise. Are you a base? Are you a mobile? And, of course, this is something that you build in. And to be quite honest with you, for general communications, you could start using your radio instead of buying airtime. And for personal communications, if everybody's within a reasonable area, and that can be offset against cell phone data. Now, the monthly repeater license fee also includes the annual simplex fee. This one you can either pay on a monthly basis or you can pay it annually. Now, the disaster relief CERT volunteer also pays 230 odd Rand a month in order to run the service. And again, I'd like to point out these are estimate fees. The subscription monthly fees are really the actual fees that people are paying at the moment, but the equipment costs are subject to the Rand dollar. So please don't hold me or EmComm to the fees that have been published in this presentation. That being said, I brought it into an hour's presentation. As we reach the 58-minute and 37-second mark, I'd like to say thank you very much. Let me bring myself up on screen here. Let me put myself down there and say thank you very much. As I said earlier, my name is Chad Milam, and you're more than welcome to contact me on voice using 082-859-2684. It is on screen. You can pause the video, you can write the number down, or you can send me a WhatsApp message. I am on WhatsApp as well. You also it is possible to send an email to sales@emcomm.co.za, and of course you can have a look at the EmComm. I'll fix that slide. The EmComm slide is emcomm.co.za, www.emcomm.co.za. And at this point, I'd like to encourage you to also have a look at disasterreliefcert.org.za. disaster relief cert.org.za, and consider and hopefully sign up as a volunteer and start preparing to help communities. On that note, thank you very much and goodbye.